Okay. Doubts. Second guess. Okay, fine. Guys, anyone having any doubt? Like time series forecasting? Yeah. Please let me know so that we'll go for the doubt clear class, or here only we will clear the doubts, guys. Please let me know if anyone having any doubts. And also if attendance will go like this type of less, the marks and all. Okay, it's fine. Let me share my screen. Only 84 people are there. Okay, we'll start. Okay, only 84 people. Maybe today other people will not join. We'll start classes. Fine. Today the new one, new concept we are going to start. It's fine. Hold on. Okay, let me share my screen. I hope my screen visible to everyone. Is my screen visible to everyone? Guys, is my screen visible to
Yes,
everyone?
ma'am.
Yes,
Yes,
ma'am, it
ma'am.
is visible.
Okay, thank you. Thank you, guys. Yeah, little bit be responsive. Okay. So, introduction. It is actually deep learning. What is actually deep learning? You people ever of machine learning? Can anyone explain what is machine learning? What is machine learning? It's fine. Be comfortable. What is machine learning? Okay. No worries. When a machine can able to read, able to understand by learning itself using some algorithms, that, that is called machine learning. Who is taking off the decisions? Our brain intelligence inside machine learning, The deep learning will work like a machine. Big task we will predict or we will solve with this. And how it will work? It will work with the neurons. We are having neurons. See, in this, here we are having one-to-one connection. These are the this is called deep learning. A deep learning is a subset of machine learning that use neural networks to decision making. It analyzes complex patterns in large data set benefited field like healthcare and finance or HR. Many. This is clear, guys. What is deep learning? Okay, no worries. Let me discuss something more. I think the starting day or someday I showed you people deep learning. Fine. Let me show the atoms. Inside machine learning, we are having a module. It will perform like brain only. See, I think my screen is visible to everybody. See, I will show here. I will show you. Now you people can see it. Yeah, here. Yes, this is the brain they are fitting. That brain is full of neural networks, which will take the decisions. Like this way, we are fitting the whenever we are going for any humanoid robot or small business use cases also. We are fitting the program. This brain is what? This is a program only. See, here we are fitting the programs in this brain. How we are doing it with the help of neural networks. Neurons. This is the not major, this is the very major part of machine learning. Neural networks, deep learning. If we are having more data, it's quite difficult for us to go with machine learning. We have to go with deep learning. Guys, this is now clear what is deep learning actually. Every brain having, they are fitting the brains with machine learning. Sorry, deep learning. Now, guys, this is clear. What is deep learning? Let's go with the neural networks. For example, biological neurons versus artificial neurons. Okay, see here. Yeah. Artificial neurons, or we are calling that perceptrons. No, this is the new concept for you people. So coding or use case practice, we should know what is it. Is this clear, guys? Any doubt, please
Yes,
let me
ma'am.
know.
Yeah,
Okay,
no
feel
doubt, ma'am.
free to, yeah, feel free to ask your doubts in the window. Okay, because what I'm expecting, what I'm explaining, you people can understand it. If you are not able to understand, let me know. I will explain many times. I don't have any problem. I will explain 2 times, 3 times, 5 times. It's fine. But end of the day, you people need to understand it. And this is quite easy also. For now. So I'm going little biology. So these are the dendrite. You people know more than me because I also did my physics, chemistry, and all, but long back ago. So these are the nucleus at the mid one and action. These are what neurons. And so how our deep learning neural network are working. See, these are the input x0, x1, x2, xn. Then here how we are having some exons, so we are also giving the some weights, the w1, w2, w and the weights, and this is having linear function and activation function. How it is working with the help of linear function and activation function, and it is giving the output. So a new artificial neural networks is working like this. This is biological one. I will share this document with you people also, no need to worry. Okay. Artificial neurons, also called as perceptrons, unit of nodes, are the simplest elements or building blocks in a neural network. They are inspired by biological neurons that are found in the human brain. How our brain, the neural network, no, the biological neurons are working, the same it will work in that program body, computer body, or robot body. Okay, I think now you people got little bit idea what is deep learning, what is neural networks, how deep learning working. Okay, fine. Types of deep learning algorithms. So, like in machine learning, also we learned many algorithms. Can you people tell any 5 algorithm names, guys? Start from regression. What are the algorithms you people learned from machine learning? It's fine. Anything is fine. We will do little recap so you people will not forget. So what algorithm we learned in regression? You people can do Google also, na? If I'm asking something, if you're not able to remember it or call it, it's fine. You can um, Google it at least. I need the answers. What algorithm we learned in regression?
Linear regression, logistic regression.
Yeah, linear one in regression, linear regression, polynomial regression, Lazo, Rees, that things we learned in regression. In classification, we learned logistic regression. Others, what about other algorithm in classification?
Decision tree, random forest.
Yes, decision tree, random forest. Okay. And also boosting Nebbius support vector machine. And coming to the unsupervised learning, guys, what are the algorithms there in unsupervised learning? Unsupervised learning. Guys, recommendation engine clustering. These all are in unsupervised learning. Okay, no issue. Now let's go to deep learning algorithm. We are having ANN, RNN, CNN, and GN. What is the full form of ANN? It is artificial neural networks. Fine. What is ANN? ANN are the foundation of deep learning, effectively recognizing pattern and making decision. These are quite simple, like logistic regression, linear regression, quite simple ANN. Predictive analytics we can do with ANN. RNN, recurrent neural networks. RNN are designed to recognize pattern in sequence of data, such text or speech. See, our speech is going on, our text as well, time series data. I told you people the time series data, time series forecasting, then speech recognition, this type of things we are using RNN. One biggest is their LSTM algorithm, long short term memory. Then CNN, convolutional neural networks. CNN are ideally for image recognition, object detection, and pattern analysis. They are widely used in autonomous vehicles, CNN. Then GAN, generative adversarial networks. GAN learn to generate new data with similar statistics to the training data. What it is doing, learn to generate new data, similar statistics. For example, ChatGPT. How it's generative? It is having some data day by day. We are giving some data to ChatGPT, and it is giving the output suggestion with the like similar data. Fine, they used to artwork, video games, and more. Generative adversarial network. So these are the major 4 deep learning algorithms. Fine. So what are the major 4 deep learning algorithm, guys?
ANN, RNN, CNN, and GN.
Yes, yes. And ANN, when ANN we are using,
For recognizing patterns and making decisions.
yes, like simpler things. Fine. And RNN,
Text and speech recognition.
yeah, it is with sequence data. Text,
Yes, ma'am.
speech, time series forecasting, sequence data. And CNN,
They are for image recognition and object detection.
yes, object detection, image recognition, these are for CNN. And GN, generative one.
For generating new data.
Okay, done. Let's go to the next one. Use case of ANN. What are the major use cases of ANN? Word embedding, convolutional mode, fully assembly model, like image recognition and computer vision. Second one is natural language processing and text analytics. ANN are used to identify object faces and sense of images, videos, revolutionizing automation and security. As well, NLP, natural language processing, also will learn, guys. So NLP stops and text analysis. And an enable machine to understand human language, translate text, and perform sentiment analysis. So you people can choose any sentiment analysis project with ANN. Strengths of artificial neural networks. Pattern recognition, adaptability, scalability. ANN excel at recognizing patterns and relationship in data, leading to accurate prediction. See, you people can tell we are already having machine learning. If we are having more complex data, then we should go with this ANN deep learning. Adaptability. ANNs can adapt and learn from new data, enabling continual improvement and high accuracy. Fine. And scalability. ANN architecture can be scaled to manage large and complex tasks efficiently, making them versatile. This is some strengths of ANN. Now, challenge in training ANN network. Overfitting and vanishing, exploding gradients, data quality and quantity. So overfitting occurs when a model learns the detail and noise in the training data to the extent that is negatively impact to the performance. Yes, in the training data, if we are having something like noise data, fine. So that will train the model and it will impact negative impact on the testing data. Vanishing exploding gradient means in deep learning, gradients can vanish or explode during training, impacting the convergence of the model. Like the gradients, like it will vanish. So again, it will impact. Then high quality labeled data in large quantity is crucial for the training. For the training without noise data, good data, it needs to be there for ANN. So these are quite challenges. Now, the key metrics for accessing artificial neural networks. What are the key matrices for accessing artificial neural networks? Like how we can measure the performance metrics. Same accuracy, precision, and recall. Guys, these three are same with machine learning. Like measure the percentage of correct identify instance out of total instances, like true positive by true positive plus false positive plus true negative plus false negative, from total to how much true positive plus false positive, no, true positive plus true negative. Then precision represent the percentage of relevant result out of total retrieved result. And recall, guys, we have the formulas, you people can revise it. So these are the metrics are same as machine learning. Popular framework for building artificial neural networks: ANN, Keras, TensorFlow, and PyTorch. So you people can use any of these one and you can make deep learning. These are the frameworks you can make the deep learning model. Anyone is fine. Keras, TensorFlow, PyTorch. Exploring deep learning with artificial neural networks libraries. Same guys, Keras, TensorFlow, and PyTorch. So Keras high-level neural networks API capable of running on top of TensorFlow. TensorFlow is developed by Google. PyTorch is developed by Facebook. Everyone is good. An end-to-end open source platform for machine learning. End-to-end. This is also open source library for touch library. This is also end-to-end. Any one you people can use it. Now building state-of-art solution with the artificial neural networks, like same data collection. Okay, curate diverse high quality data set to train ANN model effectively. Same model selection, choose appropriate ANN architecture and algorithm for the specific problem. Hyperparameter tuning, we need to optimize hyperparameter to enhance model performance and generalization. Same steps guide data collection, model selection, model building, and hyperparameter tuning. These three steps we need to do in deep learning for every cases. ANN, CNN, RNN, GN. Future implication of artificial neural networks in deep learning. Automation is there, healthcare is there, finance, HR, retail, everything is there. Okay. So this is we learned something with ANN. So let's go and learn something more about ANN. Right. Let's go more into neural network. I wanted to go, guys, little bit deep. So neural network architecture. Architecture. Right. Okay, this is different. Yeah, I think the neural net. Let's go with deep learning architecture. First, we'll see what is the difference between deep learning and machine learning. Okay, so you people get some more idea how it's different. And these are only the interview questions, guys, nothing more. No more. This, if you are going with these things, it's quite fine. Yep. Now see. What's happening here? In machine learning, fine. We are giving a car input. It in machine learning, it needs to go for data analysis, feature engineering, feature extraction. Then it will go for classification. Then it will predict it is a car or not a car. But in deep learning, we are giving an input. We don't need to do feature selection, feature extraction, and all. That steps will taken care by these neural networks. It will happen the feature extraction and the classification. It will directly give the output. This is the difference between machine learning and deep learning. Guys, now this is clear. Why deep learning is stronger and robust. Is this clear, guys? Or still anyone having any doubt? Is this clear? Guys, at least give little response now. Sai Shashank, you people are there, right? Shudesh.
Yes, ma'am, it's
Right.
clear.
Yeah, Pavan.
Yeah.
Let me know, guys. If you people are not able to understand, let me know. Ma'am, can you repeat it? I will repeat it, na? Or I will go for some easiest way. Let me know, okay? So now tell me why deep learning is. Hello. Oh, yes.
Yeah, ma'am, you're audible.
No, guys, already I'm in class. You go with the recording na for today. Yeah. With the recording today. Okay. Yeah, sorry, someone telling something. My voice is not audible.
No, ma'am, it is audible.
Audible, right? Someone told me it is not audible. So okay. So now, guys, can anyone explain how deep machine learning, deep learning, what are the difference between them? Let's go a little bit more machine learning, deep learning. What's it? Approach requires structured data. Machine learning requires structured data. Deep learning doesn't require any structured data because whenever we are going with the video, audio, speech, guys, in interview, they will ask you what is structured data, what is unstructured data. So structured data means the Excel, CSV, what you are getting. Unstructured data like video, audio, images. Fine. Now, human intervention. Yes, requires human intervention for mistakes, for feature selection, feature many steps we need human. But deep learning, no need of human intervention more. Hardware can function on CPU, but yes, deep learning many time required GPUs and all. GPU more power. Time takes seconds to hours. It will take more time because the data is more education. It will take little time as compared to machine learning. A little more time. Okay. Uses it is using for forecasting, prediction, other simple applications. More complex application like autonomous vehicle and all reboosting. This will work in deep learning. So guys, now this is very clear. What is the difference between machine learning and deep learning? Okay.
Yes, ma'am, it's clear.
No worries, guys. There is two term, forward propagation, backward propagation. I'm coming there. A very good diagram. Neural networks. You people also need to explore a little bit, so you will get to understand many things. Okay, first one. Okay, so these are the input features. For example, I am having 4 columns. These are the hidden layers. See, we don't know the iteration, how many times and all what will happen. These are the neurons. These are the neurons. This is the output. Fine. So now the hidden layer, it will work. We don't know if the hidden layer, it will work. See, the neurons are like, it will perform like this. It's quite complicated. Inside, not outside. It inside quite complicated. It's built like this. Yeah. See, this is convolutional network, deconvolutional network. See, the data is coming like this way. It's going layer by layer, layer by layer, layer by layer, and it's giving the output. Right. These are the Azure machine learning, no need of it. Caffeinet. Many net you will get, if you explore, you will get, go with the diagrams and do little exploration. Okay. So deep learning architecture. Now let's go with framework. Deep learning framework. So we already discussed how many types of deep learning frameworks are there, the major frameworks. Like TensorFlow, Keras, and PyTorch. These and other things are there, deep learning for, but we are not using that much more. Now, deep learning forward and backward propagation. So these are the major band. I will explain now how it's working back and front end. forward propagation. Backward propagation. No issue. As for example, so what's happening now? First one, these are the hidden. We are having some hidden layers, and final layer forward pass. What we are doing first, we are having some images. This is the pixel intensity, and these are the input layers. These are the hidden neurons. These are the output neurons. Fine. Now what is happening here inside, there is two terms. One is forward propagation and second one is backward propagation. Neural networks has main two parts, forward propagation and backward propagation. This refers to the calculation and storage of variable going from the input layer to the output layer. Forward, it's going forward. See, it's going forward. It's going here, 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 here. Which is the better? It will give you output. Fine. So it will start from the input layer and it will go to the output layer. This is called forward propagation. And backward propagation means what, guys? See, once we send the once we send that into hidden layers and it is giving the output one. Fine. After getting output, we seen there is a more error, like the accuracy is not good. Then what it will do? It will iterate again. So how it will iterate? It will again go to hidden and it will again go to input layer. So that one, what we are telling, that is backward propagation. And you will ask, right, it will go and come, how it will come up with more accuracy? When it will go for the backward propagation, like again for output neurons, output layer to input layer, it will update some weight. It will change, update some weight. Like that way, the accuracy will increase. Fine. So we are getting the prediction, and guys, here we are having another name, activation function. So most we are using activation function and wait. Activation function means your brain is there, your brain neurons are there, right? But still when they will start, when they will active, right? Without any activation function, how the artificial neuron will perform? We need a activation function, right? No need to worry. I will explain you people what is activation function also. Activation function transport the input into non-linear way, allowing it to learn and as well accomplish more complex task. The diagram elements include a hidden layer, that is layer 1, visible layer, layer 2, a visual layer. So what it will do, it will transfer the input into non-linear way. So it will allow to learn more. So it will activate the neurons. In the simple word, it will activate the neurons. What does activation function do in deep learning? Activation function is a non-linear property to the neural network which allow network model for more complex data. Fine. In generally, we are using ReLU as an activation function. What we are using, guys? ReLU. Fine. So see here also a ReLU activation function. Yeah. It's coming clustering and all. Yeah, ReLU activation function. Let's assume a ReLU activation function, then a layer or layers would look somewhere along the line of. So now how it's the code is, we are creating a function ReLU and we are finding the Z as hidden layer, then output layer, then we are keeping in output data. Fine. Now the weights, yeah. Same backward propagation. Backward propagation is the fine tuning of the weight based on the error rate or loss. Guys, what is the difference between loss function and the yeah, what is that is telling? Loss is like what we are having and what we predicted. For example, we are having 90% good and we have predicted 80%. So the loss is here 90 minus 80, 10%. Okay, so this is called loss, error rate. So back propagation, what we are doing, that is coming from again output layer to input layer by fine tuning on the error rate based on the weights. It will update the weights. Fine. Yeah, loss function, cost function. So guys, cost function means only y minus y hat, means the predicted actual minus predicted, but cost function, sorry, loss function means total predicted minus total loss. Fine. So it is one of the fine tuning process, backward propagation. Fine. So this is clear, guys, the backward propagation and the forward propagation. So giving proper weight make the model more reliable. What we are giving, we need to give some proper weight. So the model will run clearly and it will come up with more reliable. Once forward propagation is over, the algorithm present has a lots of loss and is not fine-tuned, then using optimization function like gradient descent for the weight are curated to give smaller loss in each epochs. So there is two term gradient descent. Why we are using? We are using gradient descent for giving the weight, proper good weights. It will update the weights in each epochs. Epochs means what? For example, in machine learning, the model will run the data one time and it will give you the accuracy. But in deep learning, you need to set up your epochs. For example, epochs equals to 30. Then the model will run 30 times. And with the updated weights and the backward propagation fine tuning, then it will give you accuracy. So you will get good accuracy in more epochs. Epochs means all the data points will run by the model single time. The new term epochs, and guys, activation function ReLU is the activation function. How the weights will update by gradient descent. What is back propagation, forward propagation, how this deep learning is working. I explained everything, guys. Now, anyone having any doubt, please let me know. Let me share a good blog with you people. setting the base, we set up the data. These are the solution, optimization, learning rate. See, these are the epochs and not input output. This is also a good one, good blog. Please do what data scientist, huh? This is also a good one. How it's really working. I will share with you people. No need to worry. So today we discussed more thing about ANN only. So we'll do a small use case practice today about ANN and tomorrow about other stuffs. Fine, ANN. Anyone having any doubt about the architecture of deep learning and ANN? Please let me know. It's fine.
No, ma'am.
You people got clear? Great. Now, can anyone explain what is the difference between deep learning and machine learning? Who is going to explain? Will note the names, guys, and definitely I will try to give little marks for that because you people need to be little responsive. Okay, let me know what are the frameworks are available for the deep learning.
Keras, PyTorch,
TensorFlow.
Yes, 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 guys. Yes, good one. TensorFlow is there. Keras, PyTorch is coming from Torch library. Okay, and then on house price. Neural networks. Model making for binary classifications. Concept range model. Non-values model for binary one. It's a good one. Keras. TensorFlow. What is the data here? What is the use case? subclass lot for days lot area Volcker propagation sigmoid function epochs. Yes, I was looking for it. TensorFlow 2.0 predict house price prediction. Okay, it's fine. I think most of the people are today they didn't join. May I know the reason? Like you people are busy with puja or spending time for some events today. Okay, it's fine, no worries. So you people wanted to do the practical today, or shall we go for tomorrow? Let me know, guys. I'm available. If people wants to go for today's event and all, let me know. We will sit for tomorrow because many of the participants are not available today. What do people are suggesting? Okay. Shashank, Pawan,
Ma'am, we'll do
Leela.
tomorrow.
Okay. Okay, guys, no worries. I got many requests also on WhatsApp. Okay, it's fine, no worries, but everything will